Today's lesson is on angles of polygons. First, we'll look at our vocabulary. A polygon is a closed plane figure made up of 3 or more line segments that intersect only at their endpoints. So the figures you see on the left are polygons, and the figures you see on the right are not polygons. Now look at our key idea for angle measures of a polygon. The sum S of the angle measures of a polygon with n sides is S equals the quantity n minus 2 times 180 degrees. Now we'll look at example 1 for finding angle measures. Find the sum of the angle measures of the school crossing sign. The sign is in the shape of a pentagon. It has 5 sides. So we're going to use our formula S equals the quantity n minus 2 times 180 degrees to solve this problem. Since the pentagon has 5 sides, we're going to substitute the n and we're going to put 5 in for that n. So now we have that S would equal the quantity 5 minus 2 times 180 degrees. 5 minus 2 is 3, so we're going to multiply 3 times 180 degrees, and we get 540 degrees. So the sum of the angle measures is 540 degrees. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. Find the sum of the angle measures of the green polygon. So first we're going to start with our formula. S equals the quantity n minus 2 times 180 degrees. We now need to figure out how many sides we have. So for the first polygon, we have 1, 2, 3, 4, 5, 6, 7 sides. So we're going to replace the n with 7. So now we have S equals the quantity 7 minus 2 times 180. Now 7 minus 2 equals 5, so we're going to multiply 5 times 180, and 5 times 180 is 900. So S equals 900 degrees. For number 2, we're first going to start with our formula again. S equals the quantity n minus 2 times 180 degrees. Now we need to see how many sides our green polygon has. This one has 1, 2, 3, 4, 5, 6 sides. So we're going to replace this n with a 6. So now our equation we have, our formula, is S equals the quantity 6 minus 2 and then times 180 degrees. 6 minus 2 equals 4. So S equals 4 times 180 degrees, and 4 times 180 equals 720. So S equals 720 degrees. Now for our second example, we're finding angle measures. We're going to find the value of x. So our first step is to figure out what our polygon is and to see what the sum of the angle measures would be. The polygon we have has 7 sides. So in order to find the sum of the angle measures, we're going to use our formula S equals the quantity n minus 2 times 180. We're going to substitute 7 for n, and then when we take 7 minus 2, we get 5, and 5 times 180 is 900 degrees. So we know that when we add up every single angle in our polygon, we'll get 900 degrees. Now we can write and solve an equation to find our missing angle measure. So 140 plus 145 plus 115 plus 120 plus 130 plus 128 plus x equals 900. We were just adding up all of the angle measures we knew plus the x, and we're setting it equal to 900. Now when we solve this equation, we get 778 plus x equals 900, and then we get that x equals 122. So the value of x is 122. Now we have some additional examples. You can pause the video and try them on your own, or you may follow along. For all 3 of these examples, we're going to find the value of x. The first thing we're going to start with is our formula. S equals the quantity n minus 2 times 180 degrees. Now we need to see how many sides we have. So we have 1, 2, 3, 4, 5, 6 sides in this polygon. So we're going to have S equals the quantity 6 minus 2 times 180. and 6 minus 2 equals 4, and 4 times 180 is 720. So S equals 720 degrees. Now we can write our equation to solve for x. So we're going to have 125 plus 120 plus 125 plus 110 plus 135 plus x equals 720. Now we have 615 plus x equals 720, and we would get 615 by adding 125 plus 120 plus 125 plus 110 plus 135. Now when we solve our equation, we're going to get that x equals 105 degrees. For number 4, we're going to start with our formula again. S equals the quantity n minus 2 times 180 degrees. This figure has 1, 2, 3, 4 sides. So we're going to substitute the 4 in for n. So we're going to have S equals the quantity 4 minus 2 times 180 degrees. And 4 minus 2 equals 2. And 2 times 180 is 360. So S equals 360 degrees. Now we're going to go ahead and write our equation. And we're going to have 115 plus 80 plus 90 plus x equals 360. Now when I solve this equation, 115 plus 80 plus 90 equals 285. So I have 285 plus x equals 360. And when I solve for x, I get that x equals 75 degrees. For number 5, again, we're going to start with our formula. S equals the quantity n minus 2 times 180. This figure has 1, 2, 3, 4, 5 sides. So we're going to have S equals the quantity 5 minus 2 times 180 degrees. And 5 minus 2 equals 3. And 3 times 180 is equal to 540. So S equals 540 degrees. Now I'm going to write my equation. And we're going to have 2x plus 2x plus 110 plus 145 plus 145 would be equal to 540. And now when I solve this equation, I'm going to get 400 plus 4x equals 540. I would get 400 by adding 110 plus 145 plus 145, and then I get the 4x by adding 2x plus 2x. Now I can solve my equation. I first would then subtract 400 on each side. So I would get 4x equals 140, and when I divide by 4, I'll get that x equals 35 degrees. Now we're looking at our third example. We're finding angle measures. In a regular polygon, all of the sides are congruent and all of the angles are congruent. So a cloud system discovered on Saturn is in the approximate shape of a regular hexagon. Find the measure of each angle of the hexagon. So our first step, we figure out that a hexagon has 6 sides. Now we need to find the sum of the angle measures. So we're going to use our formula, S equals the quantity n minus 2 times 180 degrees. We'll substitute 6 in for n. So we have the quantity 6 minus 2 times 180, and 6 minus 2 equals 4, and 4 times 180 is 720. So the sum of the angle measures is 720 degrees. Now we're going to take that number, and we're going to divide that by the number of angles, which is 6. So 720 degrees divided by 6 equals 120 degrees. So the measure of each angle is 120 degrees. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. We want to find the measure of each angle of the regular polygon. So for number 6, we have an octagon. First, we're going to start with our formula. S equals the quantity n minus 2 times 180 degrees. An octagon has 8 sides. So instead of n, we're going to have 8. So we have S equals the quantity 8 minus 2 times 180 degrees. 8 minus 2 is 6. And 6 times 180 degrees is equal to 1080 degrees. So S equals 1080 degrees. And now we're going to take 1080 degrees divided by 8 to find the measure of each angle, and we'll get 135 degrees. For number 7, we have a decagon. A decagon has 10 sides. So first we'll start with our formula, S equals the quantity n minus 2 times 180 degrees. And we're going to substitute in 10 for n, because a decagon has 10 sides. So we're going to have S equals the quantity 10 minus 2 times 180 degrees. 10 minus 2 equals 8, and 8 times 180 is 1,440, so S equals 1,440 degrees. Now we're going to take 1,440 and divide it by 10 to see how much each angle would equal. And when we divide 1,440 degrees by 10, we get 144 degrees. And for number 8, we have an 18gon, which means it would have 18 sides. So we start with our formula, S equals the quantity n minus 2 times 180 degrees. And we're going to substitute 18n for n. So we're going to have S equals the quantity 18 minus 2 times 180 degrees. 18 times 2 is 16. So 16 times 180 degrees would be 2,880 degrees. Now we're going to take 2,880 degrees and divide it by 18 to find out how much each angle would equal. So 2,880 degrees divided by 18 equals 160 degrees. Now we have another key idea for convex and concave polygons. A polygon is convex if every line segment connecting any two vertices lies entirely inside the polygon. A polygon is concave if at least one line segment connecting any two vertices lies outside the polygon. So now for example 4, we're identifying convex and concave polygons. Tell whether the polygon is convex or concave, and explain. So for A, we are able to draw a line segment between two vertices. We can draw it here, or we could draw it here. So a line segment connecting two vertices lies outside the polygon, so the polygon is concave. For B, if we draw a line between two vertices, our lines are going to be on the inside. So if we draw lines in the vertices on the inside. So no line segment connecting two vertices lies outside the polygon, so the polygon is convex. Now we have an additional example. You can pause the video and try them on your own, or you may follow along. Tell whether the polygon is convex or concave, and explain. So for number 9, if we would draw a line between two vertices, it would be on the inside. Since it would be on the inside, it is convex. No line segment connecting two vertices lies outside the polygon. For number 10, we could draw a line and connect these two vertices, and it would be on the outside. So this example would be concave. A line segment connecting two vertices lies outside the polygon. And for number 11, we could draw a line segment connecting these two vertices. We could draw one connecting these two, and they would be on the outside. Therefore, this one would also be concave because a line segment connecting two vertices lies outside the polygon. Don't forget to fill out your notes, and remember to watch the video again if needed.